So this looks like problems we've done before. Let's see. Solve cosine squared of x equals 9 sine of x. Find all solutions from 0 to 2 pi. So we could include 0, but not 2 pi. What do we do here? Cosine squared equals the sine. With other problems, we got 0 on one side. So maybe I'll subtract that 9 sine over. So cosine squared of x minus 9 sine of x equals 0. Factor, this is a problem. There's nothing to factor. If I can't factor it, then I can't break it apart with the zero product rule. So what else can I do? Well, it turns out there's a very powerful identity we can apply here that switches sine squareds with cosine squareds, and that's the Pythagorean identity. So we know that the cosine squared of x plus the sine squared of x is equal to 1, Pythagorean identity. So if I have a cosine where a cosine squared, but I'd rather have a sine squared, then I can use this to switch them out. So this tells me here, if I solve for cosine, subtract the sine squared to the other side, cosine squared of x is equal to 1 minus the sine squared of x. So I'm going to make that substitution here. So I'm replacing that right there with 1 minus sine squared of x. And I still have the minus 9 sine of x equals 0. I'd like this to be positive, so I'm going to multiply everything by -1 and rearrange things. -1 times 0 is 0. So that's going to make the sine squared positive. I'm going to write that first. -1 times -9 is going to be a positive 9 sine of x. And then -1 times 1 is going to be a -1. So I'm just kind of putting them in order, thinking about this as like x squared plus 9x minus 1 equals 0. All right, from here, that is not going to factor. Quadratic formula is what I got to use. So a equals 1, b equals 9, c equals -1. So then quadratic formula, usually we write x equals. Here we're going to write sine of x equals negative b, so -9 plus or minus the square root, and remember, slow down here, b squared. So 9 squared is 81, that's okay, minus 4 times a times c, all over 2a. So negative times a negative is a positive 4, so that's going to be square root of 85. So -9 plus or minus square root of 85 all over 2. Seriously doubt that's going to reduce if I try to factor 85. 5 goes into 85. How many times? Let's see, 5 goes into 8 once with 3 left over. 5 goes into 35 7 times. 5 times 17 doesn't help. All right, so we have now the sine of x equals that. Now that's really two different solutions, right? The plus or the minus. So we have x equals arc sine -9 plus the square root of 85 over 2, or arc sine -9 minus the square root of 85 all over 2. And again, keep in mind the sine can only equal numbers between -1 and 1. So I got to check, are these outside of that range? So remember, the sine of x is trapped between 1 and -1. So if one of these solutions from the quadratic formula is outside that, then it's not helpful to us. So let's check, see what happens there. Calculator, clear this out. So first thing I want to do is just check that fraction. So -9 plus the square root of 85 over 2. Did I type that correctly? check, -9 plus the square root of 85 all over 2. Yep. Okay, so that's okay. We can, that value is between -1 and 1. So that means I'm going to have a solution that's going to be A equals the arc sine of that. And the calculator says, yep, I love it. And then the other version, can I just copy all of that? Just change it. B equals, let's see, paste. Ooh, very nice. Change that to a negative. And okay, so that one was outside the range. So if I back off here for a second, get rid of the arc sine, I get -9 on that one. -9 is way outside the region that the sign knows about. So this one does not lead to a solution. So back here, for this one right here, that does not work since that inside here is about -9-ish. So no solution from that part. But we do get a solution from this one right here. Now, since we're playing around with the arc sine, the period of the sine is 2 pi. The next solution in line, x2, is going to, let's call that x1, is the sine is always pi minus for the other solution. So pi minus x1 is going to be the next one. So it looks like here we only have 2 solutions. And we'll do the graph to double check. So I think one solution is, let's get rid of this, that A up there, and the other one should be pi minus that number A. And the original problem said, when does the cosine squared equal 9 sine of x? So we'll graph those as 2 separate functions. Cosine squared of x. When does that equal 9 sine of x? And 2 pi is out here. So this point up here is just beyond the range I was asked about. So from 0 to 2 pi, these two curves should meet in 2 spots. 0.11, it's the one I found here. That's the arc sine. And then the 0.3032, that's pi minus the arc sine there. So within 0 to 2 pi, these two curves, the cosine squared and 9 sine, only meet in 2 places within their first period. 2 solutions. Fine print. Give your answers accurate to 2 decimal places separated by commas. Yes, we just have 2 decimal places, 2 solutions. So 0.11 and 3.03. Comma. So those should be my 3 solutions. You could enter, it says accurate to 2 decimal places. You could enter more than that, but 2 is sufficient. So always look at the graph to double check.